Welcome to Chapter 1 of Psych 201, Psychology is a Way of Thinking. In this chapter discussion, what I'm going to do is talk about why this class and Psych 301, your next class in the research method sequence, matter. I'm going to talk about consumers and producers of research. What are their goals? What are they after? Does research matter for those two groups? I'm going to talk about some fundamental concepts of the scientific method. And we're going to talk about a certain cycle that happens in the scientific literature where we publish in journals and eventually it shows up in journalism. What's the differences? What are the issues that are involved? First, let me talk about why this matters, why this class matters, and why Psych 301 matters. One thing is, I want you to understand that there is a base knowledge of information in psychology. Why people and animals behave, think, interact, and so forth in the way that they do. And what we know about these things all comes from a systematic research process that has been engaged in psychology since the 1800s and even before. And these courses, Psych 201 and 301, we want you to understand this process. We want you to get a sense of how we go about developing this information and making it into useful information for us understanding people, understanding animals, understanding how we get along and work with each other, and to actually make a difference in people's lives. For this book in particular, we distinguish between producers and consumers, and it's one of the reasons why I chose this book, because most of you are going to be consumers. Producers are those who do the research work. They're creating studies, presenting their information to the world, gathering data, and so forth. Consumers are those who use the research, either to improve their professional work, if they're clinical psychologists or counseling psychologists, or possibly they are in other professional roles, such as in the working life or other helping professions. It can help their work, but also can be for individual self-improvement, just learning about research so that your life is better. When we talk about producers, this role is vital to understand because knowing how research is produced assists your understanding of it while you're reading about it in your courses. In all of your psychology courses, both the ones you've already taken and the ones you'll take in the future, you're going to be reading research studies, reading about research studies. That's how the knowledge that's being given to you in those courses was developed. And so understanding the concepts that were used to build that research makes it easier to read that research, makes it easier to understand it and put it in proper context, to properly understand its limits and its possibilities. You also may be a student who works either as an undergraduate or goes on to graduate school and works as a graduate student on research projects. So knowing more about how the research is produced from a producer's role is going to be very important for you to be successful in those situations. Now, consumers is vital for you because that's where most of you are going to be in your lives. You're not going to be producers of research as an undergraduate or a graduate student even. And so because that's where most of you are going to be, you need to be prepared nevertheless for the bombarding of studies that will happen to you either as a professional or as an everyday person living in the world. There's many studies that are released in the news media and otherwise propagated, and you want to be able to be someone who knows how to properly analyze and think about them, to be a good critical thinker of the research that is promoted. The consumer perspective is one that is an emphasized theme of this textbook, and it's one of the reasons why I particularly like it. We always see new ideas or repackaged old ideas for treatments or issues or explanations promoted by various persons, sometimes with good intent and sometimes with not so good intent. Fads are very common in field practice. We see all kinds of things that come and go as the most important diagnosis, the most important way to treat people. Sometimes people learn a new technique and it's like having a new hammer. When you have a new hammer, everything looks like a nail for it. And it's not always the case. So you need to be equipped to deal with this landscape of a constantly bombarding with information landscape. So what we're talking about here, when we're talking about how psychologists create information, create knowledge, create an understanding of human and animal behavior, is a scientific approach. And the fundamental notion we start with for thinking of it as a scientific approach is to recognize that scientists are empiricists. An empiricist is someone who observes the world and records objective data. And that objective data is used to create theories that are used to explain how the world works. Psychologists are scientists, and they're no different in this overall method, observing the world for objective data to create theories. One way of thinking about how it works is this one. This is adapted from Sarah Mayhew, a young person who created this magnificent way of thinking about this. I've modified it only a small amount because it only needed a small amount. We have some observation, evidence, data, something we've seen. And we maybe observe some more data. And when we observe some more data, we start to think there's a pattern there. We come up with a theory to explain it. In this case, it might be the theory of triangle. But you know, that explains all the data we see. But there are other theories that could explain that pattern of three. It could be it's more complex than simply the triangle that we initially imagine might explain it. And in fact, what we want to do then is trim these away. Which ones do we really want to focus our attention on? What can we do? Any of the theories could explain the data, but a principle that we call parsimony would lead us to prefer simpler theories. Parsimony refers to the fact that simpler theories are preferred to more complex theories because all the more complex theories are calling on things that we don't have evidence we need to call on. And so the two simpler theories in this collection that I laid out in this diagram is the triangular one or the three-legged one. They both explain about as simply as the other. Now, it's important to know that parsimony is not a rule that says the others can't be true, merely that we prefer to work with simpler theories rather than more complex ones until we know we need a more complex theory. What we want to do is choose experiments that we can use to rule out theories, to falsify them. Falsification is a very important process. Falsification means that it's possible for data to be collected, that we in theory could get data, we could gather it from somewhere, and it would not fit the theory maybe. It would rule out the theory, it would falsify it. The possibility of getting that data, we can imagine it. We don't want it to go that way, we want our theory to be confirmed, but we know we could get other data. And one key thing to know about this is any theory for which any observed data can be argued to fit it can't be falsified. It's not really a scientific theory. If the data could be anywhere and still not falsify the theory, we don't actually have a scientific theory. And that's one of the reasons why some arguments that are added to by charlatans for extrasensory perception and that kind of stuff will often say something like, well, it won't work if there's a skeptic in the room. Well, that pretty much means it's not scientific, because it should always work if there's a skeptic. It shouldn't depend upon me believing in it to work. So this is the theory that we can start with, the three-legged theory. We anticipate data that'll be in that middle point if this theory is correct, that we would expect to see data appear there. But if the data shows up out there, that theory, that three-legged theory, is falsified. That means we need to come up with a new theory. We can't use the three-legged theory. It's been shown to not work. So if we get more evidence, we go from the three-legged model to see maybe we need the pentagon model. It fits the theory even better. We go back to our collection of all of the possible theories that we were looking at earlier. And so some have been ruled out. Those. We have two that are still possibilities, the Pentagon theory and the star theory. We're going to prefer the Pentagon theory over the star theory by parsimony, but it's also reasonable to assert that we haven't seen any data show up at the intersections of the lines of the star yet. We might have expected to have that happen by now, though we should do an explicit test to try to determine if we can get data to show up there. So right now our theory is a pentagon. Good. But here's the thing. That's only our theory, which is not to say it's bad. It's a powerful thing. It's a very useful thing. We don't actually know reality. Lurking out there is a reality. I'm imagining that the reality is a circle. We just got our picture of it. But we can gather more data. If we gather more data based upon our Pentagon theory, we say, hey, you know what? We really need something that's 10-sided, not 5-sided. It's getting closer to a circle. At a certain point, we would probably conclude a circle. And probably we're right at that point. But we don't know. We keep gathering data. This process of taking a theory, comparing it to another theory, gathering data that will fit one theory or another, falsifying one or the other, is fundamental to the scientific process and is seen over and over and over again in all the research that's out there. One of the ones that your textbook talks about is the famous Harlow study of infant monkeys, where they were put into a box that had a wire mesh mother that fed them, or a terry cloth mother that did not provide food. It was a specific comparison of two proposed models for why infants have attachment to their mother. Do they have attachment to their mother because of the provision of food? That was called the cupboard model. That is, moms provide food just like you get it off the shelf of your pantry. Or is it the comfort model, that mothers are providing comfort, security for an infant? Which of these two models fits best with evidence? So he did an appropriate study. These two falsifiable theories were compared in what's called a critical experiment. A critical experiment, and this is not in your book by the way, is an experiment where two competing theories are directly compared to each other in the study. They're rather hard to do, but they are out there. We do find them, and the Harlow study was a classic of this. And as I was just describing the difference between the cupboard theory and the terry cloth mother comfort theory. Another alternative for this is that there could be no preference could be seen between the two, wire mesh or terry cloth mother, and that would be that both theories were falsified, and we would go back to the drawing board either to see if possibly our methods were not sufficient to determine which is which, or that maybe we need a superior theory, that it's some combination or some complex interaction that needs to be taken into account. So in summary, what the scientific method does, oh, by the way, what we know is it's the comfort model, but your book talks about that. In summary, the scientific method is a systematic examination of the agreement between theory and evidence with the goal of refining theories. We're definitely going to spend time doing that. Our theories are good, but they always have to be improved, like we went from the Pentagon to the dodecahedron. Seeking more evidence, and then doing steps 1 and 2 forever. Your book has this wonderful diagram for this called the theory data cycle, the never-ending process of refinement. If we go through this, we will find that the theory leads to research questions, which leads to a research design, which leads to a hypothesis, a specific question we want to answer. We gather data, and that data is either supporting of the theory or it's not. And if it's not supporting of the theory, that's the orange arrows leading up. That doesn't mean we just throw our hands up and give up. We analyze what we did is our design really a good research design? Do we need to refine it? Do we need to improve it? Or do we need to change our theory? It's a solid design. There's no reason to suspect this. Let's look at the theory and maybe adjust it. Now, if it's a very robust theory that's got a lot of evidence behind it, we're going to really look at that research design a lot. But if it's a relatively novel theory that does not have a lot of support, we're probably going to lean more towards us looking at the theory a little more closely. But both are where we want to examine things. But actually, each of those steps can be looked at. Sometimes we've asked the wrong question. We haven't applied the theory correctly. We haven't really thought about it carefully enough. We've not been good critical thinkers and done good analysis. And sometimes we did not really generate a proper hypothesis, and we got to be careful of all those. But really we focus our efforts on design and theory. So this process is science. Well, science is one other thing often also. It is knowledge that we've accumulated about the world. That is a common definition. But it is also this process for attaining knowledge that we've been talking about for the past few minutes. Why do we use the scientific method? Well, in 1958, Heider noted that we're all naive scientists. And that leads to risks when we're doing data collection. We can get involved in confirmation bias and stereotyped inferences and overconfidence biases, and we're going to spend a lot of time in the next chapter talking about these issues. We're focusing today on the fundamentals of the method, the fundamental ideas behind it. This method of explaining the operation of the natural world is what the scientific method is about. It's a systematic search for truth in terms of facts, relationships, and natural processes. And we start with some basic assumptions. We assume that nature is lawful and that behavior is determined by the laws of nature. We know that it's possible, we believe it's possible to understand the laws of nature. If we did not think these things were true, there would be no point in us doing what we do. Not worth the effort. So we gather empirical data, our empiricist approach, data that is observable, that is experienced. We go through systematic observation and recording of the data. What we're doing is we're seeking general principles of how the world works, how variables interact, and we call that a theory. That is general principles. Theories are well-supported explanations that organize known data. Theories are powerful. One of the issues in common language is it has weakened the meaning of the word theory. We use it as a cast-off expression. Well, in theory, that's true. Well, and I used it even earlier in this presentation today. But the fact of the matter is, theories are powerful statements about how the world works. When we say there's a theory of evolution, we're saying we're pretty sure we know what's going on here. Theories generate questions. Good theories will do that. Poor theories don't give us any idea where we should be looking next. Hypotheses are some of the things that come from those questions. These are specific, testable answers or predictions based upon theories. I expected with Harlow's monkeys to see, if one theory was correct, a preference for the wire mesh uncomfortable mother that provided milk versus a preference, if the comfort model was correct, for the terry cloth and warm mother that did not provide food. So we have specific hypotheses, expected outcomes, and we look to see if the data is supporting. We gather the data. We gather it to test the hypothesis. And if we get support for the hypothesis, then we have support for a theory. And that builds our understanding. It's very important to recognize that we're not seeking to prove anything. There's no proof going on here. Because proof is just not logically possible. It can't be done. Therefore, the word prove should be removed from all of your writing for all courses except philosophy and mathematics. If I see the word prove in your writing in this class, it will be a points deduction in the papers, because the word prove simply does not occur in this world of work. We don't prove. We support. We have data that's consistent with. We bolster, uphold, we confirm theories. We don't prove them. We have, though, a recognition of something called weight of evidence. When we have the weight of evidence from a large number of studies that point in a particular direction, that leads us to have great confidence in a theory. That is, we're really sure that it's true. But we always know that a theory is only as good as the last well-collected data is. And so you'll sometimes see arguments about contentious theories. But look at that weight of evidence, because that's what really tells the story. And don't be too impressed by people say, well, they haven't proven anything. In fact, nobody proves much of anything. Parsimony, as you heard me allude to earlier, is an important principle in our scientific work. Sometimes it's referred to as Occam's razor. It means explanation should only be as complicated as is needed to explain all relevant data. There's no need to call on other entities that can't be observed. I don't need to call on gremlins or little elves or anything else to help us understand something. The scientific method also is used in a self-correcting fashion. We're always accepting that conclusions are tentative. And so your book talks about the testing of color to help us understand how people behave based upon the colors they're wearing. And it turns out it depends on context. We want to get into more data to overturn, revise, alter previous theories. We want to dig deeper to understand more detailed contexts for earlier theories, so that we can see that wearing red in one context changes the behavior in one direction, wearing red in another context changes behavior in the opposite direction. The other final general theme I want to get into is the publicizing of results. I'm going to talk about a little bit of my personal experience with that when we go through this. We're looking at here is the first page of a paper that is going to be coming out in December that was recently accepted for publication. Publicizing of results is often done by publication in a journal. You present your results, your findings, your paper to other scientists, and they review it. And I did receive many good reviews on this paper, and I use them to improve it. That's their job, and that's my obligation and my job. So you publish in journals. But you can also present at conferences. And in both of these cases that you're looking at here, those are a list of undergraduate students that were participants in the research in both the data gathering and in the presentations at conference and in the journal. That is something that I'm very proud of. I'm not currently working on any data gathering research, but I expect to sometime in the future. There's a couple of different methods, types of research that we get into in the scientific method. One is basic research. It's about growing our knowledge of a phenomenon. What are the influencing factors? What are limits? What are the best theories? We're trying to understand the fundamentals. Another one is applied research, which is about determining how what we know from theories can make a difference in everyday situations, solve real-world problems. There's also translational research. What we're trying to do there is take basic research and develop treatments and interventions to make a difference with problems. Now this sounds an awful lot like applied. And in fact, I'm going to be honest with you, this book's the first one I've seen that identifies translational research as a unique area of research. But I understand where the author's coming from. That the difference between translational research and applied research is the notion of development of a treatment, of forming a bridge between basic and applied. You're not sure that the theory applies, so you're trying to figure it out in translational research. Whereas applied is you have much greater confidence that it will apply, and you're simply putting it into motion. Psychological research is a particularly popular thing for journalists to write about. It's often related to everyday behavior, and it confirms or overturns widely held beliefs, so it generates discussion, website clicks nowadays. In 1998, I was the first author of a study of testosterone changes in sports fans. What we found was testosterone, a male hormone that's associated with dominance behaviors, it went up for winning fans and went down for losing fans after the game, about 20% up and about 20% down, respectively. Excuse me. I got tons of requests for radio and newspaper interviews, and I did a lot of them. Everything from the BBC and the London Times to the New York Times, to radio stations in Australia and the United States and so forth. It still pops up. I still get requests. Just a couple of weeks ago, I was contacted by a writer for a newspaper in Lubbock, Texas, wanting me to do a telephone interview. I declined. I don't do them very often anymore. I only do interviews on this work now because it is going to get old. I don't work in this area anymore. If it is a local area newspaper, that is this area within a few hundred miles of here, Frostburg, that is, it'll be a newspaper or a radio show or television show that is likely to be seen by a potential student of this university. Therefore, I am advertising Frostburg State. Or it's a national newspaper or an international newspaper. I'll still do it for those. It doesn't happen very much for those anymore. They've all seen it and done it at this point. Now, often in these stories, they do get it right, but they occasionally get it wrong. For instance, very quickly, in looking up where it's been talked about, I found this quote from Health Central, which sounds like it ought to be a pretty good thing. And the article's title is Madness Cheering to Improve Your Health. And then it describes my research. In 1998, study from the University of Utah, researchers found that a person's self-esteem got a bump when they could bask in a team's win with like-minded fans. However, it also discovered more social or cognitive effects. Researchers said the testosterone levels increased and decreased, respectively, etc., etc. Now, that first thing, person's self-esteem got a bump. That's not true. We did not measure self-esteem in this study. Didn't happen. I don't know where they got it from. I have a suspicion, though. The idea that testosterone would be affected because of basking in reflected glory behaviors is related to self-esteem. That is, people bask in reflected glory because they're trying to have an influence on their self-esteem. But we didn't measure self-esteem. We don't know. We didn't do that work. We did other work. And so the reporter went too far. The goal in journalism should be to cover what is important and to do so accurately. And the testosterone studies, I don't think, are really that important to cover. But journalism should be about what's important, but that's not always the case. It's often about what'll sell newspapers, generate clicks. Still, accuracy would be good. And because the studies are not terribly complex, these testosterone studies, they generally get them right. Generally, even with that incorrect one I was describing a few minutes ago, notwithstanding. There are risks and benefits to this as a scientist. When do you want to be willing to do it? And one thing is, people might pick up useful information for their everyday living, to become aware that, hey, that people are, will have this boost in testosterone, may change their behavior a little bit, that it's not just them being arrogant or mean. They got a hormone that's associated with dominance that they're dealing with. So that can be useful. It can create a positive impression of psychologists' work. That can be good for funding support from governments. But it can also have some downsides. It can make us look like we're wasting people's money. I mean, another person might look at research on testosterone in sports fans and say, well, that's just loony. Why are we wasting money on that? And I can't really say that they're wrong to think that necessarily. We think it's important because we think ultimately it might be connected to why we sometimes see certain cases of domestic abuse, why we see certain cases of fan rioting and these kinds of things. Those studies still need to be done, but we think that's where it might ultimately lead us. And so we think that it has value. Also, the findings can be misrepresented, and that can lead people astray. They can misunderstand what's going on, especially if studies are particularly complex. So you're going to be coming to the classroom, and in the classroom, we're going to examine some issues of thinking about research, and particularly the journalism and journal relationship. Thank you for putting up with this presentation. I apologize because I noticed as I was partway through it that I'd made a little bit of an organizational error that I'm sure most of you noticed, and I apologize for that. I'll see you in class. Bye-bye.